Now it's my pleasure to introduce Professor שלמה מגדסי, one of our more prolific inventors, one of the world leaders in 3D printing. Shlomo, please, go ahead.
Thanks, Shai. Communication. We all read books, newspapers, signed documents, and we have many, many copies of a variety of documents. We all use cell phones that we use to forward messages to a variety of people, but it wasn't like that always. Prehistoric man used to convey his ideas and dreams by cave painting, and since people have started to express themselves by writing, it is considered to be as the beginning of the modern world. Since then, nothing really has changed too much. Only at 1445, Gutenberg has invented the printing machine. He invented the printing machine, and the most famous printed item was the Bible. Since the printing of the Bible and the invention of the printing machine, information exploded all over the world, mainly at the beginning in Europe, but you could make more and more copies which will be exactly the same copies, unlike this cave painting. Since 1445, still nothing really has changed too much. You take a paint or an ink, put it on a paper or on a wall or on a carpet, and you get an image, which is information. We all have at home printers. Printers now cost about $50. Nothing very exciting about it. For me, what's exciting is that the ink costs a lot of money. And our expertise is making inks. So ink is really very simple to make. Please, we are here in closed audience, so don't tell anyone. I'll tell you a secret. All you need to do is to take pigments or material that will become a pigment. It can be a tomato, can be mud, can be ashes. You simply mix it in a food processor-like instrument, shake it, and then at the end, you end up with particles dispersed in a liquid, which is a paint. I will come in a minute to this can that you see, can paint. What we are interested is now not in simply generating blue or yellow or red colors. We are interested in making functional paints and functional inks. The meaning is that we deliver a function beyond color. What you see on the right side is a can which contains a black paint. Black paint we all know. The cars are made of, many cars are painted with the black colors. All the documents are printed by black colors, but our black paint is unique. And it is unique because the pigment can collect the sunlight radiation and convert it into heat, and the heat is used to convert water into steam, and the steam is used to generate electricity. So this process is called thermosolar power generation. So this black paint that we have developed was licensed by a company called BrightSource, and this company is making the largest thermosolar plant in the world while using our black coating, which is heat resistant, like 600-700 degrees C, and it's capable to absorb all the sunlight and then convert it into a very high high temperature. What you see here is a power plant in California, which is already producing electricity to over 100,000 houses. And the company now is working on the next plants in China and in Israel, which will be even bigger. So we learned in this project how to make paints and inks that are heat resistant. Can we use that for other applications? Yes. A few years ago, an entrepreneur came to me and asked, can we print black paint on glass? Why is it important for? When you go back to your cars, you'll see a black frame on the windows of the car. The purpose of this black paint is not for decoration. It is to protect the glue that holds the glass to the body of the car from the UV radiation. But this is done usually by a conventional screen printing process. And the entrepreneur asked us, can we make it by inkjet printing process, which is a digital process? 1 year later, we were able to make that ink. We use inkjet printers, the same as you have at home for $50, but with the much larger printer, the size of 3 by 3 meters or 6 by 6 meters. And what you do is really print our heat-resistant ink on a glass and then put the printed glass in an oven. So since we have a glue which is composed of nanoparticles of glass, this glue is embedded with the whole image within the glass. So we have an image on glass which is stable for many, many years. And the company, because of this business development, decided to move from the automotive industry into the architecture field. So what you see on the right side is examples of buildings all over the world. For example, on the left corner, you see the facade of the Harlem Hospital here in New York, which is printed by our technology, using the inks, and the company has developed the printers. We use nanomaterials in our inks. What are nanomaterials? 1 nanometer is 1 millionth of a millimeter. Just to give you a size perspective, one hair fiber, which I don't have, is about 30,000 nanometers. This is really big. So what you see here is an electron microscope of a hair fiber, and the colorful samples that you see here, you can also see them at the exhibition out there, is really gold and silver that are different than the gold and silver that you know. We can make blue silver, red gold, blue gold, yellow gold, green gold, purple silver, etc., simply by controlling the size and the morphology of these particles. What is it good for? The material really changes its properties when we go down to size. It is used in nanomedicine, a variety of applications. Professor Banin will talk later about a unique application which takes advantage of these small particles. Our expertise is in making metallic nanoparticles, and we've been working on making silver nanoparticles for many years, and we were able to find several simple synthesis processes in which we could get silver nanoparticles. The silver nanoparticles are good for making conductive inks. I will show it in a minute. What you see on the left side is how these particles are formed by simple chemical synthesis in which we take a mixture of chemicals, including vitamin C. Really very simple. And if you use a material which is called carboxymethyl cellulose that is used in ice cream, costs about $1 per kilo, you mix it in this solution and you can control the size of the resulting particles. So we have ways to manipulate the size and morphology of the particles. And what you see down at the bottom of this slide is a silver ink which is made a very highly concentrated system that is stable for a very long time. Go back to the Nano Effect. Silver melts at about 1000 degrees C. What you see here is electron microscope photographs of silver nanoparticles which are heated at various temperatures. And you see that at about 200 degrees C, these silver nanoparticles became melted. So we have a decrease of about 800 degrees C simply because we changed the dimension of the particles. What is it good for? Imagine that instead of printing black color or yellow color, we print silver nanoparticles. And if we cause these particles to merge together, we can get electrical conductor. What is it good for? All our electronic devices contain electrical conductors. So this brings me to the field of 3D functional printing. We can use this type of materials to print solar cells, to print circuit boards which are in every device, to print smart windows, displays, smartphone, touchscreen, etc. So I will show only a few examples of using this type of particles for making application in printed electronics. Here there's an example of a company called Nano Dimension. It is already traded in the NASDAQ that is doing rapid prototyping of 3D printed circuit boards. So what they do, they print our ink, then put another layer of insulator, and our ink, insulator, and you get 3D printed circuit board. So what you could do in one month, now this company can do it in a few hours also, only. And on the right side, you can see that it really works. There is a device, a small robot that can function while using our inks. You can also print electroluminescent devices. Imagine that instead of having these light projectors, you can print the light on the walls. So this is actual sample of printed light emitting device. You can also see it in the exhibition out there. It takes about 1 hour to make the whole device. This is really amazing because this is the strength of digital printing. You press a button and you get a working device. We can also make smart windows. To those of you who traveled the Dreamliner, remember that there is no shades on the windows. You only have to press a button, and then the color or the opacity of the window changes from transparent into opaque or transparent into other color. This is not yet our technology in this plans, but we have developed, together with collaborators, a nice technology that uses our inks, all printed to get, as you see there, a variety of
This box contains paracetamol pills 500 milligrams. Expiration date is March 2017.
And it is connected to Internet of Things, communication between devices. So we don't have to worry too much about labeling and then gluing, etc. We simply print directly on the requested device. We can also make transparent solar cells. So imagine that we have buildings that the windows are not really windows. They are transparent cells, solar cells. So you can see through these solar cells. Again, made by printing, by self-assembly, and using nanoparticles that we produce in our lab, and also with my collaborator, Lior Zedgar. So this is all about 2D printing. What about 3D objects? Can we make them? The answer is yes. On the left side, you see traditional way of making an object. You start with a bulk material. In this case, it's a wood. You cut this wood into small pieces, and then you have to glue this wood into a larger part. On the right side, what you see is that someone pressed the button and caused an inkjet printer to print water on flour. What happens when you print water on flour? It solidifies. Or on gypsum, it also solidifies. So this poor guy on the left side is still working on making the jar, and on the right side, we always see that we can get the printed 3D structure. You can make very complex structures, as you can see here, and all you need is really to design whatever you have in mind, press a button, and you get an object. So manufacturing is really going digital. It can be used for engineering, prototyping. For example, my students, when they need an instrument, they just simply go and print it. And it costs to my lab quite a lot of money, and it's real fun. We can also use it for future application. In the past, I used to use this slide as future application, but some of it is already here. We can print organs, artificial heart. It will happen. I have no doubt that it will happen. We are on the way to do it, collaborating with people which are coming from biology and bringing our expertise in new materials for making scaffolds. But at the bottom, you can see a personalized hearing aid that is already existing. So you can scan your ear and print this hearing aid, which will fit exactly your ear. This is in Sweden, a company in Sweden. Also, if you go to a dentist, if you go to a sophisticated dentist, most likely he will print the teeth replacement that you need. So the future is already here. No wonder that this field of additive manufacturing or 3D printing is considered as the next industrial revolution. And in America, there is a lot of money invested in research and in academy and industry. The program by Obama administration, America Makes, etc. We also recognize the importance of this field at the Hebrew University, and we established about a year ago the first center in Israel that deals with functional and 3D printing. It is equipped with top-of-the-line printers, and we encourage people from different faculties, different disciplines to come. So we quite often see people from biology and brain sciences and physics and chemistry and agriculture, and even students from art school that come and use this printing. An example of a nice collaboration is this Chanukiah that you see on the right side, a collaboration between me and Uri, while taking his quantum dots and embedding them within our polymerizable inks. He will talk more about this. I don't have time for that. We can also make stretchable materials. We have developed very recently materials that can be printed and can be stretched 10 or 11 times their original size. You can make with this grippers. What is it good for? Soft robotics. We can start printing arms or legs of soft robots. Or we can use it for medical purposes. Imagine a medical gripper, and we're discussing this with surgeons about making real printed devices that can go into our body. So there are really a lot of possibilities in this field. This was 3D printing. We are already in 4D printing. What is 4D printing? This is printed object that can change its shape while exposed to some trigger. And the trigger can be simply time. It changes its properties, its shape, by time, temperature, humidity, electrical field, whatever. So what you see on the right side is a printed medical stent that starts to move and expand to its original form after it's been printed. So you see there on the right side, it is a stent that opens up after it's been exposed to our body temperature. On the left side, you see a result of an art student who saw our work. This is, by the way, by using a special material which is called shape memory polymer. It's a polymer that has a memory. We print it in one shape, we abuse it somehow, and then it goes back by itself to the original shape that we have printed. So this art student made jewelry, which is called dynamic jewelry. You have a ring, you go out to the sun, and the ring is opened. This is really for fun. What else can we do with that? Next generation medicine. Forget the regular pills that you know from home. Imagine that you can print pills that have multi-channels, that can open up when we want, only where we want it. You see the Magen David there? There are two Magen David, small and one, and a big one. The small one is, while it is immersed at acidic condition, as we have in our stomach. The big one is the same one expanded tremendously after it reaches high pH, as we have in our intestine. So imagine printing a pill, Magen David pill, double shielding, a pill that you swallow and will open up only at your intestine. Or it can be used to protect the drug that you don't want it to be exposed while it is in the stomach. So on the right side, what you see is actual printed pills which have really funny shapes. The shapes are because you want to have a pill that is very small when you manufacture it, but when it goes into a body, it will open up and send fingers and tails and whatever to control the release of the drugs. So this is a research collaboration with Dr. Benny from the School of Medicine. So we collaborate and join forces in order to get nice, interesting results. So this is next generation medicine. We're just going to submit a patent at the beginning of, during this week, so I am free to talk about that yet. I couldn't resist seeing so many beautiful women here to talk about cosmetics. And this is an introduction to Uri's work on other type of nanomaterials. So we have developed nanoparticles of Dead Sea minerals. We simply took the Dead Sea water and converted it into nanoparticles. Women become addicted to it. Samples for that one is available also at the exhibition. And in order for you not to forget what I talk about, a recent development of nano droplets of pomegranate oil, which is very, very potent antioxidant that can go to the brain. It is sold since 3 months ago as a food supplement that can help protecting neurological diseases. What else? I don't really know. What I say is only that we have to fly with our imagination and try to print our dreams. Thank you very much.